Hello, this is Tim here. I hope you're keeping well. I haven't made a video in quite some time, probably about a year, more than a year, and I've been tasked with teaching an advanced Solidworks class in spring of 2016. So, but what is it? It's early January now, and I'm going to be creating these videos, and it's for my students who are taking ENT 261, but if you're trying to excuse me, if you're trying to teach yourself SolidWorks, I'm sure this will help you as well. These are going to be more advanced parts. Let me see if I can open this up here. I'm going to work on today. I'm going to work on a kind of an advanced mechanical part. It's an electronic enclosure. This is something I worked on years ago, and I'm going to work through creating this part, and we'll create the drawings, and it's a kind of a good refresher for getting back into SolidWorks. Over the next couple of in this class, we're going to cover some advanced modeling. We're going to model a fork. I need to get myself a calipers, and I'll do that next week. We're going to model up a wind turbine, which is quite impressive. We'll do some welding projects. We'll do some sheet metal projects. Surfacing, and this is the majority of the curriculum that will be covered in this class. So let's get down to business and get working on this electronic enclosure. So it's a 3-sheet drawing, and on the first sheet we have a couple of isometric views. You can see that we have some grey powder coat, and we have some gold. Excuse me for a sec. Some gold. It's called gold iridite. It's a coating that you coat on aluminium. You don't need to worry about this so much. You're just drawing it out. We have our different views, our orthographic projections, our section view. We have a couple of detail views, and then we have another sheet because the part is a little bit hairy. So I haven't modeled this out yet, so I need a piece of paper to write some dimensions down. Let me just get that going. Alright, I would start with this 1.6. Now, what type of dimensions are these? Hopefully you remember these are called ordinate dimensions. And drafters like to use them because they can pack a lot of dimensions into a small area, but machinists typically don't like them because it forces them to do lots of arithmetic. So let's the first sketch we'll have, it will just be a simple rectangle. It'll be 1.6 multiplied by 4.28. Okay, so I'm getting that from there, and we'll extrude it a total of 1.03. Okay, 1.03. I'm just writing this down because I'm not going to remember it all. We'll create a part. And let's create, whoops, let's not go too crazy. Let's go sketch. We'll create a new sketch. We'll create it on the front plane, and I'll lock into this origin. Now I'm going to be going a bit fast because I'm assuming you've taken either my ENT 260 class or you've gone through all these lessons. So I'm going to be motoring along now. I'm after drawing it in. I'm checking that I'm in inches, and I'll extrude it. I'll make it 1.03, and I'll go OK. The next thing I'll do, we have that. Now this is the front side of the part, and this is the back side of the part. And you have all these funny looking holes and pockets. What we'll have, what you would put in there are actually different types of connectors, electrical or electronic connectors that will connect the cables. As a SolidWorks guru, you don't have to really worry about that. So you might later, but just as of now, we're just modeling this part. So let's think about machining this pocket here out. So I have two circles, and then we have these straight lines. So let's get the circles in there first. I'll create a sketch there. Let's create a center line going across, and a couple of circles. Excuse me, I'm going to be coughing a fair bit. I'm a tiny bit sick, so I apologise for that. And let's put in an old another centre line there. We'll be able to mirror things. Did we make these equal to one another? I hope we did. What is the radius? 0.375. So what is it? It should be 0.75. Now this is a funky ISO type dimensioning standard. My friends in Asia and Europe will be used to that, but you know, I'm teaching American, so I'm going to change it to ANSI. We have 0.75. Right, now let's have a look here. The first dimension is 0.7 and the second one is 3.58. 0.7 and 3.58. So from here, that's called a datum line. 0.7 and then, oops, from there to there, 3.58. Alright. Now, this is a pretty poor way of dimensioning things, but you can see there's a circle here. This center point of that circle, and then we've got a couple of tangent lines. So we need to get 4 more circles. So let's put in another circle, like so. And it comes down. Did we even dimension it? Well, this one here, we got a dimension on this one. 0.34. Let's bring this down here. So from that line to there, remember, whenever we dimension, we go from a line, if we can, a full line to the center. And then what is it? It's 1.12. 1.12. Alright, and what's its radius? Its radius is 0.2. Does that make a 0.4? Let's slow down here for a sec. 0.2. I need to slow down here. It doesn't look right. It has a diameter, radius 0.2, diameter 0.4. Now what's going on with this? This looks like 0.778. Alright, let's close this down. Quit Skype. 0.778. Okay. Alright, we got that. 0.778, and let's just double check that. 1.12. Okay. Okay. This something doesn't look right there. What am I missing here? 0.2. 1.12 will bring it down there. This is 0.75. 0.78. Yeah, I'm just thinking aloud here, so don't worry. I'm having a bit of a brain fart. 1.12 to there. That seems and 0.78. 0.778 is what it is. And that's 0.7. Yeah. Do I need to make this bigger? Maybe its diameter is 0.4. There it goes. That's a bit better there. 0.4. Yeah, sorry. Okay. And then let's get a tangent line between there and there. Now, did that just give me a tangent line? Nope. So let's put it in. Okay. I'm going to delete this. I'm going to mirror it over. And let's trim this a bit of a way. Okay. What do I want to do? Will I trim this? Okay. Let's mirror this across here. Be a good lad and do it there now. Come on, entities to mirror. Mirror about here. I'll go okay. And let's see, can we do that here? Can we go from U to U? We'll make these two tangent. and let's just, let me delete that for a second. I'll make that coincident. Okay. Oh shit, okay. Now what we'll do is I'm going to mirror all of this across here, and then I'll get a line that goes from the 12 o'clock to the 12 o'clock and the 6 to the 6. And let's trim all this away. I'm using power trim. So just keep going. I'm after losing some dimensions, it's alright. Let's put them back. 0.38, and from there to there is 0.7, and from there, okay, that's fine. Now what's going on here? I need to make this tangent, that goes black, everything goes black, lovely. Excuse me. Right, that wasn't too bad. How much do we want to cut this down? Now I know I have a boss here. I'm just going to extrude this all the way down, and then I can add that in later. So what is it? It's 1.03 minus what? 0.525, which will give me that dimension there. 0.525. Alright, let's do here, let's exit sketch. We'll extrude cut. I'm going to go 1.03 minus 0.525, and I'll go okay. And now I have this cut out. This is the back side, that's the front. Now, okay, I have that. This shape here, it's kind of a circle with two straight lines, and then this small one and that small one and that small one are all just going straight through. We could put those in. So I'm going to draw this one in, and then I'm going to draw that, and then I'll array that over. So let's create a sketch on here. It doesn't really matter where, that face or that face. I'm going to draw in my center line. I'll draw a circle and a circle over here. I'm going to draw a straight line and another straight line. And let's have a look. Its diameter is there anything there? Diameter is 0.6. I'm getting that from there. Alright, 0.6. And I'm going to put in a center line because I'm going to use my symmetrical relation. I go you, and you are all going to be symmetric across that center line. I need a dimension here. It's what is it? 0.7. Look, I could just go you to you and make that concentric. Now let's be careful there now. Let's just double check that. 0.7 is good enough. And then what is the distance from there to there? This is not another example of poor dimensioning. 0.975 minus 0.425. That you would put a dimension in for the machinist. That's a bit crazy. But you know, I was young when I drew this. It's been a long time since I drew this part, or when I drew this up in Solidworks for the first time. 0.975 minus 0.425, and I'll power trim this. Okay, there's that. Let's put some manners on those dimensions. If you're not getting this mod diameter coming up on your screens, don't worry about it. It's some I don't know what it is. It's some configuration. It's just it's in there. It's in one of the settings that I couldn't be bothered figuring out. But don't worry about it. Well, let's have a look at this this one here. It's okay. It's a diameter of 0.48. And how far does it go over? So from this edge, or from the other edge, we'll say, let's pretend we're drawing this one here, 2 inches, but it's from the other edge. So from there to here is 2 inches. Alright, and I'm going to draw my 2 lines again. Okay. And what is the distance between them? 2.4, what the hell, 2.495 minus 2.065. Is that right? 2.495 minus 2.065. What's that, 4.3 or something? 2.495 minus 2.065, 0.43, and I'll trim it. I'm sucking on a sweet here now, so if I'm harder to understand, it's because it's from my sore throat. Okay, we'll get that. We'll exit out of this. See, I have them on the same sketch. That's okay. I'll go extrude cut, and I'll cut this region out. First, I'll go through all. I'll right click on this. I'm going to go show. I like my shared sketches, and I'm going to extrude cut. I'll click this. Don't be like that. Extrude cut. Hit this sketch. Hit this region now, and I'm going to go through all. Why am I doing those on separate features? Is because I'm going to do a linear pattern on this. So I click here, just this one. This is the direction I want, along that line, or this line, or any of those lines will do in that direction. Okay, I'll flip it, and what is it? It looks like it's, let's have a look. So it's 1.35 minus 0.7, what is that, 0.65? Yeah, 0.65. Alright, and I'll go OK. And now I have those cut out. I'll right click on this sketch and I'll turn it off. Now what's next? I got that. Probably should have put in this hole as well. Just that circle right there. That circle just goes straight through. We can add all this other information later. Can I edit that sketch? Yeah. I'll put a circle in. Now, what is it? 1.55. And what is its diameter? I'll look here. 0.45. Alright, 0.45. I'll exit the sketch. I'm going to right click on this guy and I'll add that region as well. Alright, we're getting there. Now, I'm going for the low lying fruit now at the moment. My brain's getting a bit tired. This front looks a bit funky. We'll worry about that later. Maybe let's put in these 4 holes. Now, if you're looking from the front here, hopefully you know that these are called counter bore holes. These 4 guys right there. What they're for is our bolts will go through those. And on the other side, you have these holes. That's where the bolts go through. Now what the hell are these 4 holes for? These 4 holes are actually for pins. There's pins that go in there, mounting pins. You don't when you start designing stuff, you're gonna have to worry about that. But these 4 pins, 4 holes are for mounting pins that will align this gizmo with something else. So let's throw those in. We've got 4 holes. And what is it? It's diameter 0.190 with a depth of 0.150, 150 thousandths. So let me see if I can do this with Hole Wizard. Notice that I clicked on the face first, and then I went straight into Hole Wizard. Now I'm going to have a hole, and it's saying all drill sizes. So what's 0.190? Can I show custom sizing? I'll just make this 0.190. I'll go positions. 1, 2, 3, 4. I'll just put in my center lines. And I'll just make this guy and that vertical, this and this vertical. Just the usual stuff. This should be no trouble to you. Okay, let's go back. 1.165. So from there to there, 0.165. Whoops. 0.165. Lovely. And what is it down to the other one? 4.115. Give me what's going on here? Yeah, it doesn't like that symmetrical relation. Let me get rid of that. Let's try that again. There you go. 4.115. Okay, and 0.165 again. Now hold on. 0.165. Okay. Right. Everything goes black. It's fully defined. I'll go okay. Let's see. This is going to be called as a number 97. That's not a good idea. We need to find out what size 0.190. What is that? All drill sizes. Let's have a look. Drill sizes. Decimal drill sizes. So what am I looking for here? Decimal equivalent 0.150, 0.191 is a drill size 11. Okay, so we go back. We call this a drill size 11. We'll turn off this custom sizing. How deep are we going? Let's just be careful here. Number 11, end condition, blind. Now what is it? 0.150. Nothing. Alright. Wrong way. There we go. Excuse me. Alright, so what are these for? They're 4 holes to mount pins in. Dowel pins. Now we got that. before we put the 4 bolt holes in, we got to come down, we got to get a rectangle here. So let's draw this rectangle with the 4 fillets on it at the front. Now, what is the fillet size? 0.2. And it's 0.15 from there to there. I think it's an offset of 0.15 all the way around. Okay. Alright, how far do we extrude this down? Again, don't worry about this step up business. It's coming down what is it, to that line there, 0.325. Okay, so I'll go extrude. Let's try that again. Extrude cut 0.325. And I got that. Okay, what's easy? We have that so far. I'm gonna add in, let's put in the 4 counter bore holes that sit in the front face. That's easy enough. Okay, now what are they for? It's right here. 4 times 0.129 is the small hole, 0.219 is the big hole, and it's saying 0.112 is the depth. Now I don't know, are they for what size of a hole are they for? Maybe, would they be 632s? I'm not sure. Okay, I'm gonna guess they're 632s. But anyway, I click the face, click on hole wizard, I hit space bar, I go normal 2. What is it? Is it a countersink? No. Is it a threaded hole? No. Is it a taper tap? No. Is it a counter bore? Yes. So I'm going to put in a size 632, but I could be totally wrong. I'm going to put in 2. That looks big. Way too big. Would it be 440? That seems very big. For a binding head screw, nah. We're going to put it in for a socket head cap screw. Big, very big, too big. A socket head cap screw. Let's look at the dimensions here. Show custom sizing. So the big one is 0.281. Let's have a go. Look, 0.28. It's way too big. So it's not a number 6. Is it a number 4? No, it's not a number 5. That's for sure. 0.219. There it is. There. 0.219. 0.112. So what are they? They're 4 counter bore holes for a 440 socket head cap screw. Anyone that does machining or metal work in the United States is going to be well used to those types of screws. So if you're over in Europe or Asia, you're going to be a little bit baffled, but you're used to nice metric sizes, but that's just the way it is. So anyway, let's have a look. 0.342 and 3.94. So let's make these 2 vertical, and let's make these 2 vertical. These lads horizontal and horizontal. I just forgot that number. What is it? 0.342. 0.3. Let's try that again. 342, 3.94. We got that. I have a dodgy keyboard. 0.34 and 1.26. 0.34. Okay. Now go back to type, and I'm going to go end condition true all, and I'll go OK. Alright, so those 4 holes there are for our counter, our socket head cap screws that would go in there. Alright, we have that. That's easy. Now what's another easy one? Alright. This detail B it's actually for a mini. It's for a mini B USB connector that sits in there. What we want to do is this shape. We want to draw this oblong, or this rectangle with the 4 fillets. We may as well draw all of this. Let's do it all at once, and we'll make it a shared sketch. Let's have a look. Now where is it going? So it's going down here. Alright, let's create an old sketch here. I'll get that. Let's put 4 fillets on it. What is it? It's 0.038, 38 thousandths. 0.038. 1, 2, 3, 4. Alright. I'll zoom in here. I'll go up and over and down. Now it's 0.25 minus 80 thousandths. .25 minus 0.08 will give me that 0.17, and then we have you have to be careful here. No, is that right? Okay, so this is the datum here. That's my origin, and then we're saying 0.165 times 2 from end to end. 0.165 times 2 will give us that. And then we have what is that? That's, I'm guessing it's from there to there is 0.17 as well. That seems very high. 0.17. Now it looks the same size. And 0.85 times 2. Alright, what I'll do is I'm going to get an out center line from there to there, and I'm going to go, you two guys are going to be symmetrical across it. This seems very big. Oops, I have to hit the microphone. Okay. Now what is that radius? Is it 8 places, 38 thousandths? Okay. I'm going to trim this and quiet you, and let's put in another 2 fillets. Bang, and there we got that. and let's put that line back in from there over to there. Okay. Alright, we need to look a location dimension. Damn it, it needs that from the center of the hole. Okay, I'll put a circle in. And I'll make this guy from there to there coincident, and then 90 thousandths. So from here to here, try that again, is 0.09. Okay, 0.09, and is that right? If I move this over, yeah, that seems to be okay. Now, is everything alright? Yeah, we'll find out. So it's 1.05 from there to there. So from there to there, come on now. 1.05. And what is it from on the over? It looks like it's 2.605 from that edge. 2.605. 2.605. That doesn't seem right. 2.605. There you go. Now, don't worry about why is the circle blue, because it doesn't have a dimension. It doesn't matter because that's just locating. We're going to put a 080 type threaded circle in there. So hold on. I'm going to exit this. I'm going to go extrude cut, and I'm going to go through all. Just this portion. This portion goes all the way through. Okay? A connector sits out in that little cutout. And then I'm going to turn this on, and what is the depth of this? Now, do I have that called out anywhere? Aha, 80 thousandths deep. 0.080 thousandths. Okay. So extruded cut. I'll just hit all these regions, and we'll make this 0.08, and I'll go okay. What does it look like? There you go. So let me just grab another sucky sweet here. And then we have our 080 threaded hole with a depth of 60 thousandths. So I click here, I click on Hole Wizard, it's threaded 080, which is a tiny little hole, blind. The thread is going to be 0.060. I'll hit, come on now, normal 2. Let's see how this works. 60 thousandths thread. The reality is you'd have to give 2 dimensions there. You'd give a dimension for the length of the depth of the pre-drilled hole, and then the length of the thread. So the length, I'm assuming this is the length of the thread. What Solidworks says is if you want 60 thousandths of thread, you've got to give me at least 0.1 inch of a drilled hole, which is true. I'll turn off the sketch, and now I have that. Let me just take a look at that. Does that look right? Yeah, it looks good. Alright. What's next? Yeah. This is a boss with 4 threaded holes. A BNC connector sits in there. Now, let's add the boss, and then we'll add the 4 threaded holes. You're probably noticing this text is easy. I'm not worried about this. This is a little bit hairy. I'm gonna have to think about that a little bit. I'm leaving that to the last. Let's put the boss in and get the 4 holes, the 4 threaded holes. So this is the back side and that's the front. Okay. It's this guy right there, isn't it? Yeah. So I'll sketch on this face. I'll hit the space bar. I'm going to draw a center rectangle. I'm going to click that edge. I'm going to go convert entities. Now let's go down and have a look here. This is 0.7 is the square. I'll make this guy and this equal. Now what's the fillet? The fillet size is 0.1. Easy. I couldn't be arsed reading what that's saying, but I know it's going to work, right? So just go OK. Let's exit that and then let's extrude it. If you didn't remember to convert to entities, that circle there, you would have an entire boss here. You want that circle. We need that hole going through it. Now, what is the height of this? Hopefully you're decent enough at looking at section drawings. You can see that the boss is this guy right here. Let me just write this down. It's 0.767 minus 0.525. 0.767 minus 0.525, and I'll go OK. I have my boss. I click on the face. I go to hole wizard. I'm going to go to threaded hole. Now, what type of threaded hole is it? Can you see 440? Now, you guys that probably don't remember threaded screws. Typically they start off with a 0.80. That the screw size is 0.80 threads per inch. That's a very fine small screw. Then it goes up to 256, 440, 632, 832, 1024, 1032, 1/4 20. So any Solidworks guru that is drafting in the United States will know those numbers off the top of their head. So what is this? This is a 440. What is the depth? It's 0.12. So you can notice that Solidworks will automatically calculate like the depth, the blind hole depth. It doesn't have to be this, but the blind hole depth will be a little bit more than the depth of the threads. Okay, so they're 0.25 from either side. Okay. Look, we'll just go, you guys are symmetrical and you guys are symmetrical. And we'll just make this 0.5. Come on now. There's a few little, I'm using SolidWorks 2016 and there's a few little bugs in it still. I'm not quite sure. Maybe I just gotta get used to it. But there you are. There's your 4 threaded holes. If you're asking yourself, well, I can't see any threaded holes there. Look, you can just go Tools, Options, Document Properties, Detailing, Shaded Cosmetic Threads. There you go, and you can see it. We could probably, if I take a section view of that, there's loads of meat there. We could make those holes a lot bigger. I bet you in real life they were made a lot bigger, a lot deeper. We could make them 0.25 easy. Let's make that 0.3. And now we got more threads to hold that screw in, or to hold that connector in. Okay, that's that. What's next? Alright, I may as well deal. Look, I'm going to deal with the text. We'll do the rectangle and then the text. There's a few other things just yet. I have also a couple of cutouts here as well, just to make, just to give it a bit of a shape. Alright, I'm going to take a break. Alright, so let's flip this around. Right, and let's create a sketch on here. I'll just bring this over here now. So it looks like it's 0.46 and 2.25. So from there to there, make it 0.46, and then from there to there, 2.25, and 0.224, and 0.462 from there to there, 0.462. Alright, and then we have a couple of fillets. 64 thousandths, 0.064, 0.064, we'll go OK. Alright, so we have a nice little pocket there. Now let's extrude that down. It's saying platform is 50 thousandths deep. Fair enough. I'll make that 0.05. Alright. Now, so we have three power, audio 1, audio 2. Okay. So what we do, I'll go create a sketch on here. I'm going to go text, and I'm going to type in, I'm going to probably do it in 3 different groups. There it is, it's over there somewhere, power. I think I can click this and put this in. So there's power. Maybe I can do all this at once. Audio 1. That looks good. Audio 2. Too much. Let's bring it back. Alright. I'll go OK. And then I'm going to exit sketch and I'm going to hit extruded cut. Now I hope this doesn't work, and it does. I was hoping it wouldn't. If you're having a hard time with that, I'm going to go extruded cut, alright? And I'm going to bump this up. I'm going to make this like 0.02, and I'll go OK. And I've created what is this called? Engraving. If that worked right off the bat. Now if you have 2015, I don't think it will. And what you might have to do is when you click on it, can you double click on it? You might have to, is there anything you can do here? If you can link to property, bold, italic, rotate. There might be a button that you can convert that text into just lines, like a polyline. Maybe that's not in 2016. If you're having if you're extruding it and it won't find the regions, it's because of that. This is 2016. It worked right off the bat. I have a feeling you're going to have a little bit more trouble with that than I had. There's a button there that you can convert all that text into actual polylines or lines, if you know what I'm saying. Alright? Excuse me for 1 second. Alright. Alright, I'm going to, the nice thing about this is I can draw one of these and mirror it over to the other side. So let's do that. Before I do that, I'm going to put in some fillets. If we look at this from the very front, you got like fillets there and all over the place. Now what size are they? 0.125. Alright, now let's have a look. Fillet on the features place, 0.125. And I'm going to go 1, 2, 3. See, if I screw it up, I can just click it again. 3, 4. I think, if can I do this at the same time? No. What I'm going to do is I'm just going to do one, and then I'm going to do another fillet, and I get nice ball ends. I think you actually have to have them as separate fillets. You might be able to do them as one. Let's try it. I'll just delete that one, and I'll edit this. See, I don't think you can. Ah, yeah, you can. Yeah. Okay. I'm getting rusty. Alright, so we have that. It's looking good. Let's save this before we bloody lose the work. I'm going to call this Electronic Enclosure Project. Alright? Yeah, save your work way more often than I've just done. Save it every 10 minutes, 5 minutes even. Okay. Alright. I'm going to forget about this boss here. I'm just going to add a big boss, and I feel like there's a fillet on it. Let's look at it from the front. Yeah, there's just a cylinder coming out, and you have this inside fillet. Now let's go back and see if we can do that. It looks like it's 0.75 is the outer one. So let's create a sketch on here. And let's click on the edge. Let's go convert entities. Let's try that again. 0.75. Good stuff. Alright, how far do we need to bring it out? So we're here, and we want to come out to there. So what is it? It's 0.325 minus 0.95. 0.095. 0.325 minus 0.095. And I'll go okay. I did a cut extrude. Let's try that again. Something doesn't seem right there. 0.325 minus 0.095. Okay, that seems a bit funky. Alright, yeah. That's the outside. Okay, right, so there's a bigger one. Okay, we got that. The 0.75 on the outside, and then it looks like the diameter of this cut coming in with the fillet is hopefully we can do this, is 1 point, I gotta write this number down, 1.8. I know this is probably a pain to be following me along, but it's good practice. Just number crunching and figuring out everything goes. Alright, we'll create a sketch there, and I'll draw a big circle in, and its diameter is 1.865 minus 1.235, and I'll go extrude, and what is it? It's 0.525 minus 0.095. 0.525 minus 0.095, and I'll go okay. And we have these little cutouts. Yeah, I knew that. Okay, now this is, you're going to learn something new here. So what can I do? I want to put in we have a breakthrough here, and the reality, yeah, this is why I screwed up. Yeah, it's that. This is why they're not as deep as they are. So I'm going to show you a nice little trick. So what to do? Let's put these guys. I'm going to grab this feature, and I'm going to put it under that feature. And I'm going to, let's go back and edit this, and let's make this let's make a 0.120. In the drawing you would also put do not break through, because you would tell the machinist that you're getting very, very close and there's a chance you'll break through. Right, 0.12. I will make this 0.125 and I'll go OK. Now I'm also gonna, before I'm gonna undo that one, or just lift up the bar here, and I'm gonna put something in before it. I'm gonna put that fillet in. So let me just show you here for a second. This would be this is a pocket, and then we have a fillet inside of this. This would have been done with a thing called a ball end mill. Okay, just because you're good at Solidworks doesn't mean that you can be a good, well, you will, hopefully most of you will turn into good designers, but you need to understand how your parts will be actually fabricated. So it will be worth your while, now that you're starting to get into more advanced stuff, is to learn a little bit more about how CNCs work and how they machine parts. You don't have to become a machinist, but it's good to know actually how they machine parts. So let's get a fillet of 63 thousandths. 0.0625. Let's hit this edge here, and now I got that, and I'm going to drop this guy down now. Alright, now let's get an old section view and see how close it is to, for that, those old holes do they interfere. Yeah, they're not too far. Yeah, they're miles away. Okay, that's good enough. What else are we missing? We're missing that chamfer. No, that's a fillet of 32 thousandths. 0.032. Okay. And now we've a boss here we want to get. So let's have a look. It's a big circle, and then we've got two tangent circles. So it's not too bad. I'll create a sketch on here. Let's pick up that center. Let's click all these edges and go convert to entities. And what is the diameter? It's a diameter of radius 0.425. 0.425 multiplied by 2. And I'm going to click this circle, and I'm going to go convert to entities. Lovely. I'm going to get myself a perimeter. Let's have a look. Just a perimeter circle. Screw you. One there and one there. Now, what is it? Radius 0.15. I'm going to trim it. Excuse me, guys. Now, why is that blue? It's gone now. Let me get one of these sweets into my throat. Alright. Just do the same down here again. Make this equal. Alright, let me just have a look here. Okay, so this boss just goes up. Now it's this lip right here. So it's 0.325. I'm too tired now to be doing arithmetic in my head. 0.325 minus 0.235, probably 90 thousandths, but I'm going to check it. Yeah. Alright, I'll trim this. I'll go exit sketch. .325 minus 0.235, 90 thousandths. Lovely. I think that's it. We're not done. Here, there's a little cutout here to grab. Well, I think it's just for aesthetics, to be quite honest. But alright, we'll do this one first. It's machined with a ball. You can see that looks like a ball end mill. Alright. So I'll create a sketch on there. Point 2 from the front. and 0.93. When you've done this part, if I was in your shoes, so I would redo the whole thing. Excuse me. I would redo the whole thing yourself. I'm holding your hand here, and I would go back to the drawing and I would just redo the whole part yourself. Maybe in a couple of days' time. Let's have this point 4.03. All right. Tidy up your dimensions. Now, how deep does it go in? It goes in at 0.1 depth. 0.1, and I'll go okay. And you're saying to me, hold on a sec. Let's put the fillets in first. Now, what is it? It looks like it's a radius 0.125. Okay. 0.125. And I'll go okay. Exit sketch, and we have that. Now, let's put in a fillet. I'm not sure it's going to be able to do this. 0.125. Yeah, there it is. Okay. Radius 0.125. Seems like quite a big ball end mill, but anyway, it is what it is. So that's kind of what that looks like so. All right. I should have. Lovely, I got a nice top plane there I can mirror across. I'm going to hit mirror, features to mirror. I'm going to mirror these two guys. Come on now, and the fillet, and go okay. I love it. Now let's go on this side. Let's create a sketch on here, and let's do this. 0.27 from the top. 0.27 and 1.33. 1.33, and we have 0.27, lovely again. 0.27 and 0.73. What's the fillet? 0.1, or it's actually 0.125. Now what's the depth? The depth is 25 thousandths. 0.025. And I feel like we've got a chamfer going on there. A chamfer going around the edge. It's okay, it's 25 thousandths of a chamfer. Let's have a look. I don't know if I'm doing this right. Is it the other way around? Maybe it's from, we've just done this. Yeah, it's the bottom line, because if you look at your outside dimensions, so yeah, you're picking this. You're going to get different numbers if you choose different lines. So that's your 25 thousandths there. The reality is, it doesn't really. The reality for the part, it doesn't change the functionality of the part. Okay, let's mirror it across there. Okay. Now, I feel like that's everything. The only thing we're missing here, just I am in no mood to do the drawing tonight. I'm going to do it tomorrow or the next day. But let's finish up the powder coating and gold. So let's save it. Let's hit the beach ball. Appearances. Metal. Polished brass. Polished gold. This thing is not made out of gold. It just has a covering or a finish called gold iridite, which is used in electronics. So I'm going to paint the whole. we can paint the whole thing gold and then add. Is that the easiest way? No, 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 no. Let's paint it all grey and then spot the gold. So let's undo that. Let's have a look and see, is there a painted aluminium powder coat? It's not quite what we want. No, it's not that. We're probably going to have to find a metal. Is there a powder coat? I doubt it's anything close. Probably the closest thing is a satin finish. It's we'll go with a low gloss textured. It's not really textured. We'll just do a dark grey satin finish. It's too dark. We'll do a light grey satin finish. That's about right. That's probably close enough. It's not really. But anyway, look, the function for this first view is that you would send this to the painters. Believe it or not, this thing gets machined by a CNC, and then you're going to send it to a painter, an industrial painter, and they will powder coat it. They will finish it first. They'll put it in a tank to get the gold iridite. Then somebody will tape it off, put masking tape on it, and cut it, and then you paint it with using a powder coat. That's good stuff to know too. So we'll anywhere that has metal there's electrical circuit board is probably making contact. Anyway, all right, let's go back here and go back to metal, polish gold. Now I'll drag this out. I don't want the part, I want the face. And this is kind of a pain. Can I do this? Can I do the whole feature? Yeah, that's good. Is that right? And then here I'll just do the feature. That's good too. Just a feature. And the last place you're going to have, I'm sorry guys, I'm just thinking here aloud. Yeah, it looks like these holes. You're going to learn about all this stuff when you get your first Solidworks job. You're going to hopefully learn about coatings and CNC machining, all of that. But look, that's the part. I'm pretty sure I'm not missing anything. If I give it a material, and let's say it's 1060 alloy, did that change? Did it change? I don't want it to really change the thing. If I make it, I'll just give you the number. If it's 1060 alloy, and I go to evaluate and I go mass properties, it's saying that it's 0.28 pounds. Well, let's give it a bit more precision. 0.279 pounds. If you're getting 0.279, you're laughing. Okay, so that's it. I wish I could change that colour there a little bit, but that's your part. 0.279 pounds is what you're supposed to be getting at. I'll save it. I hope this lesson wasn't too boring, and I hope you got something out of it. Tomorrow night we will create the drawing. I wish I could figure out how to get that. Get a better. Let's get the low gloss, light grey low gloss. There we go, and now we're back, and it keeps it as a 1060 alloy. Alright, look, that's the part. I'm going to do the drawing tomorrow. So good luck with that.